Hi, I'm Paul Cox, I'm Slooh's Community Manager, and I'm here to guide you through the huge variety of activities you can do with Slooh's telescopes, whether that's using specialist astro software or learning about astronomical discoveries by following in the discoverer's footsteps. And that's what you're going to do in this activity. We'll guide you through all the steps necessary to replicate the discovery of Jupiter's 4 largest moons by Galileo Galilei over 400 years ago. Now you'll find all those individual steps lower down on the page, but first let's remind ourselves of how the discovery story unfolded and changed our view of Earth's place in the universe forever. Now, other than the sun and the moon, the ancients saw 5 spots of light in the night sky. They wandered through the heavens. They were known collectively by the ancient Greeks as wanderers or planetos. They deemed them, all of the ancients deemed these 5 mysterious wanderers so important that they named these planets after their gods. And the brightest of these lights was known as Marduk by the Babylonians, Odin by the Norse, Zeus by the Greeks, and you've guessed it, Jupiter by the Romans. It was their chief deity, god of the sky. Now, with nothing more than their naked eyes to observe these mysterious objects, the ancients really had no idea what they were, and it took over 1.5 millennium for this understanding to advance any further. And this happened in 1609. A Florentine genius named Galileo Galilei became the first person to point a telescope to the night sky. The moon was an obvious first target, but he soon shifted his gaze to these 5 wandering planets. He looked at Venus as well. He saw that, unlike the stars, they remained pinpoints of light through his magnified telescopic view. The 5 planets appeared as fuzzy discs of light through his basic instrument. A cheap or toy pair of binoculars will give you the kind of view that Galileo saw through his rudimentary telescope, although he saw it as something a bit better. On the 7th of January 1610, he pointed what he called his very excellent image to the planet Jupiter. Now, he observed what he described as 3 little stars near the planet. Although they looked like the other stars, he noted that they were arranged in a perfect line, a string of pearls. The following night, the 8th of January, he pointed his telescope to Jupiter once again. He later wrote, I turned again to look at the same part of the heavens. I found a very different state of things, for there were 3 little stars all west of Jupiter, the nearer together than on the previous night. He went on to write, I therefore concluded and decided unhesitatingly that there are 3 stars in the heavens moving about Jupiter, as Venus and Mercury around the sun, which was at length established as clear as daylight by numerous other subsequent observations. These observations also established that there are not only 3, but 4 erratic sidereal bodies performing their revolutions around Jupiter. Now, he continued his nightly observations, and on the 13th of January, that 4th star appeared. Over the course of several weeks, he saw that these 4 stars were carried along with the planet as it wandered against the background stars. Now, Galileo's discovery that these were moons of Jupiter orbiting the planet was a pivotal point in the history of astronomy, because his observations revealed that not all celestial bodies revolved around Earth. This was actually the start of what became known as the Gallileo affair, and that culminated in the trial and condemnation of Galileo Galilei by the Roman Catholic Inquisition in 1633. Now, stepping back a little, the Catholic Church had adopted what was called at the time the geocentric system, the astronomical model developed by Ptolemy in the 2nd century and used for more than 1500 years. It basically placed the Earth at the centre of the universe with the celestial bodies orbiting it. This was actually contrary to what the ancient Greeks thought, however, so it was already a backward step. Now, it wasn't until 1514 that this geocentric view was challenged. That was the year that Nicholas Copernicus, a mathematician and astronomer, formulated a different hypothesis, which became known as the heliocentric system, or heliocentric system. And that placed the sun, rather than the Earth, at the centre of the solar system. Now, his discovery, which he'd only shared with friends for fear of scorn by others, finally appeared in his book. It was On the Revolutions of the Celestial Spheres, and that was published just before his death in 1543. So, against this backdrop, Galileo's discovery provided for the very first time direct evidence in support of the Copernican system, and showed quite clearly that the Earth wasn't the centre of the universe. But it took the Catholic Church some time to agree with this model, and the repercussions, are still felt to this day. I think it was in 2008 when the Pope had to cancel a visit to one of the universities in Rome because of protests by staff and students over what the Pope had written about Galileo as late as 1992. Anyway, back to scientific and experimental method rather than religious dogma. Galileo published these observations in Sidereus Nuncius, which translates as starry messenger. You can read that on one of the links on this page. Now, in March, he wrote that in March 1610, and this is what he wrote. I should disclose and publish to the world the occasion of discovering and observing 4 planets, never seen from the beginning of the world up unto our time, their positions and the observations made during the last 2 months about their movements and their changes of magnitude. And I summon all astronomers to apply themselves to examine and determine their periodic times, which it has not been permitted me to achieve up to this day. There's an invitation. What better way to mark this incredible story of discovery than to answer Galileo's calls to examine and determine how long each moon takes to orbit Jupiter? And that's exactly what you'll do in this activity. Just follow the steps on the activity page. You'll start by scheduling your Jupiter missions, examining your images, logging the positions of the Galilean satellites over 9 or more nights to monitor and record the position of the moons, just as Galileo did over 400 years ago. We've even provided a template that you can use to record your observations from the wide field telescopes. Now, if you want to take the activity even further, we've provided some software, and we show you how to align those images and animate your images so that you can compare them to Galileo's original sketches. Now, shout if you need any help, and please share your results with other members in the clubhouse. That's all for this activity intro video. Have fun and feel free to drop me a line at paul@slooh.com if you run into any problems. Have fun.